Hi class, as promised, I'm going to give you another video boost. The video boost is going to be on the resonance theory that was covered in class last week. But first, I want to remind you of a little synthetic issue. If you want to make a syn diol, I mentioned this very briefly and I said you are responsible for learning it. Okay, it's in the textbook. What you do is you take an alkene and you add potassium permanganate, and this would be in water. This is a very colorful reaction. This reactant is purple, very dark purple, beautiful purple color, and the product is what is called a vicinal diol. Okay, another way to do the same process is to take osmium tetroxide, which by the way is much more toxic than potassium permanganate. You'll notice this is one of your all-purpose oxidizing agents. The byproduct, by the way, in this reaction is manganese dioxide, and manganese dioxide is a brown solid. Okay, with osmium tetroxide, it's a very similar reaction mechanistically, or it's analogous. And in the second step, notice it's not a one pot. You add sodium bisulfite and water. Okay, so that you don't think I totally neglected you on this reaction. Okay, roughly what's happening. And the two, you would write similar mechanisms for the two reactions. So for example, if I have a ring and I had, oops, I'm ahead of myself. If I had this alkene and I added KMnO4 in water, I would obtain the so-called cis diol. Can you see that? Mm-hmm. Cis diol. Okay. Now the way this reaction is believed to occur is that in a more or less concerted fashion, the manganese, which is in a 7 oxidation state, so that's how I'm drawing the bonding, forms an intermediate, a cyclic intermediate, in which the two oxygens more or less join at the same time to the oxygens. Okay, and when you treat this with the water in the second step, these two bonds break off and they become OHs, and you get you can see you could cleave MnO2 out of that. Actually, I think this bond breaks out, so I'm going to move that out. Okay, so you're not going to be responsible for that mechanism. And the reaction with osmium tetroxide is very similar. If you had an alkene, the reaction would be roughly like this, okay, to form this osmium intermediate, okay, and then you cleave it off with the sodium bisulfite, and once again you're making OH groups there, and they will end up being syn. They'll either both be on the top face or both be on the bottom face because they are delivered at the same time. Now, synthetically, okay, synthetically, what's my time frame?
You have 5.5 minutes left.
Okay. Synthetically, if you want to make, let's say you want to make this has to be made, that's a retro arrow, through an epoxide. The reason is this is an anti-alcohol. And then the epoxide could be made directly from the alkene using metachloro perbenzoic acid and benzene. This would have to be opened either with acid or base, and as you know, I'm kind of a little more of a fan of the base reaction, so I'd use NaOH and H2O, but it could also be done with H3O+, okay, and you can work through those mechanisms. But that's like a little synthetic strategizing. Now, synthetically, if you wanted to make, I don't know, I'm using rings simply to show you the stereochemistry. So say I wanted to make this. When I see that, I immediately think of adding potassium permanganate or osmium tetroxide or something like that. Okay, so thinking backwards, I would go directly to the alkene, and then to the alkene, I would add KMNO4 in water, or I would add osmium tetroxide and NaHSO3 in water. Okay? You're going to have to learn those, so work on them. All right, another thing I wanted to go over. What's my time?
You have 2.5.
Okay, I'm going to stop here, and I'm going to continue on another video. That was important.